Thanks everyone for dialing in today for the last of our T&E talk. I hear from the SERC leadership that we've had very high attendance for these talks. And so I'm thrilled at the level of enthusiasm around test and evaluation from the SERC network. For our last talk, we have an outstanding speaker that I am thrilled has been able to share an hour of our time with us today. Dr. Sandra Hobson is currently serving in an acting capacity as the Deputy Director for the Director of Operational Test and Evaluation. Her full-time job, when she's not acting in the Deputy Director slot, is the Deputy Director for Strategic Initiatives, Policy, and Emerging Technologies. Prior to this appointment, Dr. Hobson was first appointed to the Senior Executive Service in 2014 as the Deputy Director in the Office of the Director of Operational Test and Evaluation, in particular looking at live fire test and evaluation. Prior to her appointment as an SES, she supported DOT&E in other capacities as a research staff member at the Institute of Defense Analyses, and is also as an action officer and aircraft systems and weapons system specialist in the office in DOT&E. During her tenure there, she provided guidance and direction on survivability and lethality evaluations for major Department of Defense acquisition and weapons systems, including things ranging from the F-35 strike fighter, K-46, Navy P-8, as well as many other large acquisition systems. Early in her career, Dr. Hobson worked at the National Institute of Aerospace and NASA Langley Research Center. Dr. Hobson earns her Bachelor of Science degree in Aerospace Engineering from the Naval Academy and has the Doctor of Philosophy in Aerospace Engineering from the University of Maryland. She is the recipient of a National Fellowship for Exceptional Researcher Award from the United Nations Education, Scientific, and Cultural Organization, and has 2 Secretary of Defense medals for meritorious civilian service. And it is awesome to have her here with us at SERC Talks today, and looking forward to her sharing her perspective with you all. And so with that, Dr. Hobson, I will click through our disclaimer and turn it over to you.
All right, thank you, Laura. Thank you for the invitation. I do appreciate being here and sharing some of our challenges in OSD on all matters related to operational test and evaluation. So for folks that are not familiar with operational test and evaluation, I will focus a little bit on explaining, who we are, what we do, and why we care about T&E. And then I'll get into some of our challenges as an office and as an organization in OSD. So Laura, if you don't mind forwarding. Okay, so a little bit about DOT&E. Again, I'm not sure how familiar you all are with the Office of the Director of Operational Test and Evaluation, but our roles and responsibilities are rooted in the legislation. We were, established back in the 80s, and the primary, charter was really for us to do an independent evaluation of performance of DOD weapon systems and platforms and equipment in operationally representative and realistic conditions. We are an oversight organization, so we don't actually execute test and evaluation. We oversee those activities as performed by our service counterparts. Services each have their own operational test agencies, and they work with the acquisition program managers and executives to frame the adequate operational test and evaluation program for any given acquisition system that will allow us to evaluate the performance of that system with some level of confidence. And again, the idea is to test the system as it would be used in actual operational environment in combat. So we're focused on production representative test assets, operated by trained units and, executed in operationally realistic environments as best as we could replicate those. And now we'll get into some of the challenges that we have with that as the complexity of the operational environment continues to increase, and as the complexity of our weapon systems and equipment continues to increase. So that's our primary mission, is to oversee those efforts, oversee the test and evaluation plans, the execution of test and evaluation programs. And why do we do that? And the ultimate objective is to write and or provide an independent evaluation of the performance of DoD weapon systems in combat. So our office publishes on a regular basis reports that get sent out to Congress and the Secretary of Defense and other acquisition stakeholders. And those reports typically include an assessment of the adequacy of the test plan that was executed to support such evaluations. And then it includes our assessment of the performance of those systems. And we focus on three major metrics: operational effectiveness, suitability, and survivability. And survivability against the range of threats. So we break that out by category of threats, meaning kinetic and non-kinetic, to include cyber and similar. We also focus on test and evaluation limitations. So we focus on, test and evaluation infrastructure, and any shortfalls that we observe that precluded us from evaluating certain aspects of the performance. So if there are, limitations with our ability to represent the operational environment, there are limitations with our ability to test certain things in open air range. So we have to rely on modeling and simulation. Then we have to speak to the adequacy of the modeling and simulation tools. And we have to understand what the verification, validation, and accreditation process was for that. So we provide Congress on an annual basis our assessment of the health of the test and evaluation infrastructure and really the resources that we as a department have to adequately execute operational tests. And lastly, I would offer the big responsibility is the one for policy and guidance. Because we have such a big platform and visibility into essentially a wide range of practically most critical DoD weapon systems and tools and equipment in our portfolio, we do have the luxury and insight into a wide range of capabilities and limitations. And it really is our responsibility to capture those and to catalog them and analyze them and then update test and evaluation policy and guidance to advance the T&E state of the art. So that's in a nutshell kind of who we are and what we do. Laura, next slide for me, please. And in case you were not familiar with the DoD structure and organization, we are in the Office of the Secretary of Defense, and our director is a political appointee, and he reports directly to the Deputy and the Secretary of Defense. We're currently in the middle of waiting for our next director, which is the reason why I'm acting principal deputy, because our principal deputy is the acting director. So we're waiting for our new director to check in. He's been nominated. We're just waiting for him to get voted on, and hopefully he will join us here shortly. But it is a political appointed position, and like I said, we're anxiously waiting for a new director to help us. To help guide us in the new direction. Hopefully he will continue with some of the initiatives that we had already started. Next slide, please. So I mentioned operationally representative environments a few times, and this is just to illustrate what I really mean by that, and really to foot stomp and to set the stage for some of our initiatives. So the complexity of our technologies, the systems that we're acquiring and that we're fielding to include hypersonic weapons, directed energy weapons, autonomous systems, AI-enabled systems, all of those technologies are radically changing, and the complexity of those is driving the need to transform the way we test them. And not only are our systems changing, those of our adversaries are changing as well. So the complexity of the operational environment has been significantly increasing, where our warfighters are facing a very dynamic environment that is changing in both space and time. And, we've been recently talking about the multi-domain operational environment. I would offer that we've always kind of been playing in multi-domains ever since, the aircraft were born, essentially, that added that third dimension. But now we added, of course, the space and we got the cyber domain. So we have more domains, but we also, all of those domains are more connected. So we really have sensors that are, shooters across the services, across the domains. They're trying to talk to each other. They're trying to communicate, all with the intent to optimize their, position in the battlefield and optimize their, probability of mission success. So there are platforms and systems, again, and sensors that are talking across those domains to again achieve mission success. So all of that adds to the complexity of the operational environment and the complexity of the warfighter and the mission commanders to make split decisions based on the vast volume of data that they're getting from those sensors. Who's supposed to be doing what and when? Are the information that we're getting accurate, or have they been tampered? In the cyber domain, what is the reality? Where does the truth lie, and how do we figure that out? And how are we ensuring that we got the right information and that we got the right information at the right time? So all of those, again, there's lots of volume of information. The battle space is really becoming more and more complex, and the warfighter is being thrown with a bunch of information that they need to slog through to make the right decisions. All the more reason why AI-enabled systems are becoming more and more important, and arguably the next big war is really going to be in the information domain and the cyber domain aspect of the domains of domains, if you will. So I'm just throwing this out there as context for why we in the T&E community are thinking ahead to manage this or figure out how to manage these complexities and how to set ourselves up for success to really enable us to evaluate how our weapon systems and their interoperability and their connections and the command and control infrastructure will actually work in such an environment. So next slide, please, Laura. And again, this just emphasizes a little bit more, kind of what I just talked about. Data is becoming a big driving factor. Information is becoming a big driving factor, and whomever can manage the data in a most optimal way, I think will stay ahead of the other side in a way. And really, as it states here on the slides, delivering information and data at the speed of relevance so that the warfighter can make those split decisions and make accurate decisions is really kind of where we headed. And our ability to evaluate that, the ability to evaluate this environment is becoming a challenge for us because it, as I will talk a little bit later, it will require a combination of new tools, new T&E methods, new M&S environments, new digital twins, new ability to connect ranges with the virtual environments. All of those things will have to be put in place for us to adequately assess mission effectiveness at that level. Next slide, please. We in DOT&E have recognized this, right? And it's not just us in DOT&E, the whole department has recognized this. And we just, had a conversation with one of our industry partners, and they're kind of wondering the same things. We cannot, focus on, testing, individual systems or platforms, because they're no longer operating as individual systems and platforms. Their effectiveness really depends on the effectiveness of a range of other systems that they're working with in a particular battle space. So how do we do that? And those are some of the questions that the industry is wondering. And so we're really talking to academia as well, so we can then, introduce, them to this problem and kind of solicit some support and feedback in helping us tackle this, what I view as a really challenging enterprise level problem. So what we've done in DOT&E to really emphasize this, we stood up a division that is focused on that. And, Laura mentioned it earlier. It's the Division for Strategic Initiatives, Policy, and Emerging Technologies. Prior to that, our deputies and our staff has really been, kind of focused on tactical stuff, overseeing individual programs and, T&E programs for those acquisition systems. And we didn't have dedicated staff or time to look what's coming up and to prepare for that. So we set up this division. It's really intended to be forward-looking, and it's intended to be focused on whatever current and emerging challenges that we as a department recognize. So we intend to work with stakeholders, both internal and external, to help us resolve some of the challenges that we have identified, and maybe even some that we may have missed. So next slide, please. So, and this is what I've, this graphic is what I lifted from a report that the National Academy of Sciences have recently published on our behalf. We asked them last year to really do a good scrub of the health of our T&E infrastructure and give us an assessment of whether or not we're ready for, the 2025, 2035 timeframe in terms of what's coming up from the science and technology point of view, what's coming up from the adversarial side of the house, and whether or not we as a department are ready to evaluate those systems in such an environment. And they actually came up with some really interesting recommendations and really foot stomped some of the things that we had already recognized. But it was good that we got an independent look at that and an independent assessment that kind of matched what we already thought was going on. So they focused, or they recognized the need to do systems assessment for the complexity of the multi-domain operational environment I talked about earlier. They recognize that in order for us to be able to evaluate our systems in such an environment, we really have to rely on digital tools, digital engineering, digital transformation, to set ourselves up for success. And then in terms of how we do T&E, they also recognize the need for continuous testing. And I'm not sure how familiar you are with the DOD T&E process, but we do have different organizations responsible for test and evaluation. So we have USD responsible for developmental testing. We got DOT&E responsible for operational testing, and then we also rely on testing, and we kind of stitch those various data points together. But what we're advocating here is for all of those entities to get together at the beginning of the program and figure out, okay, how do we plan this T&E program from the beginning to the end, and with the end really being questionable nowadays because of the software-intensive systems and because things are changing even after the systems have been fielded. So where is end, going to be in the future? Traditionally the end was arguably, when the acquisition, milestone authority declares full rate production decision, and they go in and produce systems in mass quantities, that was arguably the end of the T&E program. But again, with software-intensive systems that are continuously being updated and provide incremental improvements to the delivered capabilities, or in the case of autonomous or AI-enabled systems, where the system is continuously learning new things as it's being placed into different environments, where does that T&E end, and does it? And what does that really mean for the T&E community? So we are advocating for a more integrated test and evaluation, where, you know, the idea is to leverage, you know, the data as soon as the data is being generated in that particular system throughout the acquisition cycle. And I will speak to this a little bit later on. But what this graphic really shows is, you know, there is a need, you know, going back to data, there is really a need to start collecting test data in a way that allows us to do data analytics, that allows us to do aggregate assessments, that allows us, you know, various stakeholders access to that data, and that allows, you know, that data to really inform the acquisition process, you know, more optimally than it has in the past. It speaks to the need for modeling and simulation in digital environments that again connects, you know, the physical to the virtual to adequately represent that operational environment. So those are some of the things that, again, we are looking at from a DOT point of view to try and figure out, okay, how do we do that, right? Because they're all very complex problems and very enterprise level challenges that no one organization or no one service can tackle on their own. Because an operational environment today is it's a multi-domain, it's a multi-service environment. And doing the assessments in silos by service, by domains is not going to serve us well in the future. So we need to start thinking differently, and we need to start preparing that environment in a way that will allow us to do and test really the way we will fight. I think that's all I had to say on that one. Laura, if you don't mind switching to the next one. So we in DOT&E have, again, recognized the challenge of what's coming, you know, what's today and what's emerging. And we've, like I said, we've stood up a new division, but we've also generated a strategic plan to go after some of these challenges. And that strategic plan was really informed by two things. It was informed by the National Defense Strategy, and it was informed by some of the science and technology advancements that we've observed. So those are the two major strategic or major drivers for the DOT&E strategic plan. And they have led to this DOT&E strategy, which really is focused on 5 key areas that I highlight here. We got the software and cybersecurity area, again, with the software intensive systems and with cyber being a threat that is very dynamic and unpredictable and very complex. We really felt we needed to have a focus area in this area to help us move, help us advance or improve the cybersecurity posture of DOD and DOD systems, and to really help us understand how to test these software-intensive systems that I mentioned earlier. So again, given our assessments, we still think that the DOD cybersecurity posture is not sufficient to prevent adversaries from degrading our mission capabilities. We think we still don't think we're performing cybersecurity testing at the necessary scale, frequency, and speed, or with adequately representative threats. The attack surface is growing exponentially, and so are the adversarial capabilities, but our capabilities arguably are growing linearly. And that is really expanding the gap, that we think will affect our ability to conduct assessments in the future. We also think that we lack validated tools and the data framework to provide operationally relevant, model-based, data-driven test and evaluation that we would need for an adequate to support the acquisition across its life cycle. Then we have the next generation T&E capability focus area. Really, what we mean by that is, we really think we need to prepare the T&E community for testing of advanced warfighting capabilities, such, like I mentioned earlier, hypersonics, directed energy weapons, AI-enabled systems. And also we need to prepare for testing under, like I mentioned several times, realistic operational conditions, given the advances in adversarial capabilities and the complexity of the, very dynamic nature of the operational environment. Another aspect of this key area is focused on the advancements of test and evaluation methods. Examples would include models, virtual environments, analytical approaches to accelerate evaluations and similar tools that are really, I think, rooted in digital transformation technologies. So that's kind of where we are on the next generation T&E capabilities, is really to, again, recognize the fact that there are new technologies that are coming up. Again, autonomous AI-enabled systems being the most complex ones. And so are we ready as a department to test them? Do we have the right methods, tools, infrastructure to test our systems in an adequate, electromagnetic spectrum environment, or in an inadequate space environment, nuclear environment? Take the threat, the density of the threat, the capability of the threat. How well are we representing that, and how well are we understanding what the capabilities of our own systems are in such environments if we don't have the ability to replicate them in open air ranges, in laboratories, or in modeling and simulation? So we really need help in all those areas to help us replicate that environment, be it virtually or in laboratories, and it will likely be a combination of all of the above to help us, again, adequately characterize what our systems are capable of in such environments and where the limitations are, so we can inform the warfighter and let them know, hey, in this particular environment, this is what you can do, these are the risks, these are your limitations, so they can adequately plan their missions around that information. The next line of effort is integrated T&E lifecycle. Like I mentioned earlier, we really think that the DOD T&E community is segregated among various test organizations, and they have different rules or authorities, and they have different resources and different objectives, and that's really, in a way, hindering us as a department to optimize the T&E programs across the acquisition cycle. The programs are probably less efficient, and arguably in some cases, because of that, we have limited ability to identify operationally representative problems earlier on in the acquisition cycle, because we haven't exposed the system to operationally representative environments sooner. We really limit our ability to identify such problems until much later, when implementing design changes and fixes will be much more cost prohibitive. So we're really working with, again, USDR&E and any help we can get from you guys in helping us figure out, okay, how do we plan for an integrated test and evaluation program? This is a system that we want to field, and we are in the prototyping stages. How do we design that test and evaluation program that will allow us to understand how the program is maturing along the way, and is allowing us to understand once it's ready to be fielded, that we have optimized that test and evaluation program along the way, and that we have done all the right things to correct the design deficiencies, and that, the interim decisions that the, acquisition community needs to make have been adequately informed with performance data, given the intention. So we're working through what we're calling an integrated decision support key that allows us, again, to identify what information we need to provide as a T&E community to the acquisition community to inform their decisions at that particular time. So those are some of the challenges that we're facing, and that we could use a lot of help in this area to help us, again, change the way we do test and evaluation, including collaboration across the various communities to help us, again, optimize T&E effectively. And then the last two are kind of, supporting all of the, the three above it and then some. Again, it's the digital transformation. It's a big term that we in the department have been using, but really what we recognize is that arguably we're falling behind industry standards in adopting digital technologies to design, develop, test, and sustain our weapon systems. We're largely driven by very static, document-centric processes rather than dynamic, information-centric processes. And that really, again, constrains our ability to shift left, like I mentioned earlier, and to integrate and automate what are today considered lengthy T&E processes, and really has suboptimal acquisition outcomes. So we really want to leverage digital technologies and advances in that area. And this could mean a lot of things, right? And it could be very, very broad, but it could start simple. So for example, in our organization, we see a bunch of test and evaluation plans. We write a lot of reports, and those are all stored in PDFs. But there's really no way for us to do data analytics. To be perfectly honest, we really have no ability to find certain things when we need them. So if I want kind of a historic look of a certain program, or if a particular staff member departs and somebody else comes in to replace them, we don't really have a good database that allows that person to pick up where the previous person left off. So we don't have a good storing system of the data that we have, and then we don't really have a good system to get into those reports and pull out the information that would be important for, pick an issue that you want to address. So what we're looking for is establishing a data architecture that will allow us to store the information that is in those Word documents, PDF documents, in a way that is searchable and that we could analyze, no matter what the question is. So that's one step. And the second step, or one of the other steps, which is kind of broader, is, digitize the whole T&E process. Can we model the acquisition process? Can we model how we're meeting the requirements? And as more test data becomes available, can we, instead of having a data or document-driven test and evaluation plan, can that be digital? And by digital, I don't mean a PDF. I mean, no kidding. There's a database of information that allows us to inform the next phase of T&E. So those are the kind of big ticket questions that we're asking the community to help us define and to help us execute. So, and oh, by the way, Congress has been very interested in that, and I mentioned, I don't know if I mentioned later on, but there are a couple of NDAA sections, Section 231 being one of them, where they really are interested in, okay, how is Department of Defense implementing digital technologies, and give us some examples. And if you don't have examples, give us some examples of how you might. So we're working with USDR&E to provide some examples to them, to kind of give them a sense of, you know, yeah, we do recognize the problem and we're trying to address it, and here are some examples where we think we could do this, and here's the value added that could then potentially inform new policy and guidance in this area. So that's on the digital transformation. And then the last line of effort, and but not least, is on workforce expertise and partnerships. And this is really important because, again, the complexity of these systems, like I mentioned earlier, is really increasing exponentially. And we can put out guidance, you know, all day long, but if we don't have the people with the right skill sets to implement it, then it's all for nothing. And moreover, we won't be able to generate new policy and guidance unless we do have deep expertise in some of these areas, because we won't be able to figure out what to do. So we are, you know, we are in the process of, you know, determining, what is the status of our T&E workforce? What, you know, where are their strengths? Where are their weaknesses? And then based on that, what programs, educational programs do we need to put in place, or what recruitment strategies do we need to attract the right skill sets and to address the gaps in expertise and capacity. You know, some may argue we don't have enough. Others might say we have enough. We do have enough. We just don't have the right skill sets. So wherever the truth is, we really do need a structured educational program to encourage and enable continuous learning in all of these areas. Because again, you know, I got my PhD 2007, and arguably a lot of things have changed since then. And without continuous education and training, I would offer I will and will be falling behind a power curve here. You know, software. How do I do that? What do I look for? What are the challenges? You know, how do I lead our staff, and how do I lead the T&E community without that fundamental knowledge of that? So I'm a big fan of training and education. I'm a big fan of learning, but we need to really work with our stakeholders to come up with a good training program for our workforce to be able to support that. And of course, we don't have to do everything ourselves. We want to be able to partner with industry, academia, and so forth to call out on particular expertise when we need it and help us expedite certain things. So I know I spent a lot of time on this slide, but the rest of my slides really elaborate on some of this, and I'm not sure if it's really needed to go through those. And I know we have 20 minutes or so left. Let's see, Laura, let's go through them and see if I missed something, and I can elaborate on those. So software and cybersecurity T&E, I talked about the attack surface, how it's expanding at exponential rates. I have some details here for folks to digest. And I did emphasize the fact that we really need to start working on tools to be able to visualize, model a network and visualize and model the effects of cyber on our network, on our software. I would offer we don't have those tools today. We don't have tools that help us automate certain things that are kind of trivial, so that will allow us to concentrate on things that are more stressing on our systems. You know, we got some great red teams out there, but they're stretched thin. they need either more of them or they need tools to enable them to do things faster. Next slide, please, Laura. See if I missed something on, yeah. Next generation T&E capabilities, I already talked a little bit about that. And again, hypersonics, directed energy weapons, those are our big ticket items. And of course, autonomous and AI-enabled systems. We got a huge effort going on with the Joint Artificial Intelligence Center that the Deputy Secretary is leading. They want the department to be AI ready by 2025, and we're still spinning wheels a little bit, or we're making progress, but we're trying to again prepare ourselves to succeed. And we're working with the Test Resources Management Center over in USD&E to help us with the T&E infrastructure to develop the virtual ranges. I talked about the data management already. Again, it all goes back to data and our ability to collect the data and tag the data for future use. And then, of course, the modeling and simulation tools. So I talked about those already. Next slide, please, Laura. See if I missed anything on the integrated T&E. I don't think so. Again, we're trying to merge without losing the individual objectives of there's a need for contractor testing, there's a need for developmental testing, and there's a need for operational testing. So we don't want to lose those objectives, but we do want to figure out how to potentially integrate those in a way that allows us to optimize the T&E program at large and to help us introduce efficiencies in the way we do business. And there again are potentially a lot of tools and methods that academia can help us with in identifying how to optimize this entire process for us. Next slide, please. Digital transformation, I talked about that as well. Let's see if I missed anything. Right, so as I talked about, the multi-domain operational environment is really, it's all about the connections of the various systems to command and control systems, to the various sensors, volumes of data being passed through to execute certain missions. So we won't be able to test all of that in an operational representative live environment. So we will need virtual environments essentially connected with some physical environments and a hybrid environment with a lab environment, whatever the case may be, and a digital, twin of the particular system. What does that mean? What does that look like? How do I VDNA that? And with things changing dynamically, my model will have to change dynamically. How do I ensure an agile VDNA process to ensure that whatever my model is I'm confident in its output? So all of those are challenges that we're facing and that we could use help with moving forward. The last one is, I think, is the workforce. Or if you don't mind flipping through the next one. Yeah, and I talked about this one, right? So it's again, we got folks, and they're very smart folks, but again, we're absorbing a lot of the workload that is being imposed to us as a result of new things coming up. So we have. So I'll use DOT&E as an organization as an example. We haven't really grown in size, but we have absorbed the cyber problem or the cyber challenges. We as an organization have, dealt with the cyber T&E challenges with the existing workforce. So we had to scramble and figure out how to train our own workforce to enable us to do adequate cyber T&E oversight. So we've absorbed a lot of the work with the existing workforce, but we really need to come up with a better strategy and figure out again our recruitment strategy. You know, what is it that we have today? What is it that we need given some of these emerging issues, and what programs or efforts do we need to put in place? So we do in our organization have ongoing effort where we are assessing our existing T&E workforce, and that will hopefully help us inform the strategic plan and initiatives moving forward on how to the workforce deal and implement some of the current and emerging T&E issues that we are facing. And I think that's my last slide. Right, so SIPIT, which is our Strategic Initiatives and Policy and Emerging Technologies Division at DOT&E, we've really been chartered with tackling some of these enterprise level challenges and needs. And again, we can't do this in isolation. All of these are enterprise level problems that require enterprise level solutions. So we are looking for support and help across government labs, academia, industry, and so forth to help us expedite the implementation of these strategic initiatives. And with that, I think I left us with about 15 or so minutes for any questions, feedback, thoughts.
Excellent.
Yeah.
Thanks, Dr. Hobson. And we have some questions that I'll pepper in from the chat already. So the first one comes from Ed Kennedy, who thanks you for your great presentation. And his two questions. I'll ask the short one first. Has DOT&E's Center for Countermeasures contributed insight expertise, et cetera, to standing up the new CIPET? Is that how you pronounce your new acronym? CIPET?
We do CIPET. Yes, Center for Countermeasures is actually in CIPET's portfolio. And that's another thing that I probably should have mentioned. I wasn't sure who my audience was and how detailed of information you guys had. But CIPET also has kind of absorbed some of the, I'm calling them secondary missions that DOT&E has been tasked with through DOD directives. You know, Center for Countermeasures is one of them. Joint Test and Evaluation is another. We got the Joint Technical Coordinating Group for Munition Effectiveness that's responsible for the development of weaponeering tools. We got our TETRA group, that is our T&E resources threat analysis group that helps us collect the intelligence data that we need to support T&E evaluations. So CIPET has absorbed all those activities, and really the reason is that, you know, all of them are really supporting not just one particular deputy in the organization or not particular service, but really they're supposed to support across the organization. So Rodney Rogers of CIPET is definitely part of the team, and we're working with them to figure out how CCM can help us execute some of these strategic initiatives.
Thanks. And Ed's next question is, what role, if any, do you see for digital twinning in OT&E?
Right. Digital twinning is my opinion is and there are opinions in the organization, the OT&E organization, that are very skeptical about that, and rightfully so. But digital twins, I believe, are an important aspect of operational test and evaluation, because we will not be able to evaluate our systems in physical tests, and having a validated and accredited digital twin, I think, will be really important to iterate on the design, to understand, you know, some initial features of the design and the performance of the system, will allow us to pair it with the environment that we wanted to evaluate it in. So I do believe that digital twins are important. I think they're going to be a critical aspect of operational test and evaluation. I do want to caution everybody that we really need to come up with a way to make sure that those digital twins are adequately validated and accredited for the intended use.
And I have actually a follow-on to the digital twinning question around what kind of intellectual property or data rights do we need, kind of feeding off of your validation of the digital twin? What insights do we need to those models to be able to use them for DOT, for independent assessment from an operational task? Or is
that's
a
an
policy lens
right.
there? Sorry.
Right, and that's an interesting point. That's why I kind of mentioned the intended use, because digital twins, I think, means different things to different people. What does a digital twin really mean? Do I have to model every component and every wire in the particular system, a physical system, or am I just, modeling the, in a case of an airplane, the aerodynamics of it? What exactly do I mean by digital twin? And how, and then depending, and it will depend on, the use of that digital twin. If I want to address the vulnerability, if I want to use it to assess the vulnerabilities of that system to a cyber threat, the fidelity of certain things in that digital twin may be different than if I want to use it for something else. So that's going to be driving, I think, the fidelity of the digital twins, and maybe we as a department, in coordination with our stakeholders, really need to define what we mean by digital twin. I do think terminology and semantics and lexicons are really important, because different people think of digital twins and similar things in different ways. So I think we need to come to a consensus on what we really mean by certain things. But yeah, I don't really know how to speak to the data issues, proprietary and all of that. I know that's a big concern, because if we're talking about virtual environments where you have all services playing, all services use different contractors, that then now need to share that data, which is proprietary. Not to mention that data gets aggregated into different classification levels. So all of those are issues that we as a community need to recognize and need to find a way to deal with to really enable some of these initiatives. So I don't think I have a good answer for you on that one, actually.
All right, well, I've got many more questions to throw at you. So one from Tom McDermott. It seems like the strategy requires a significant investment in test infrastructure as well as workforce. What are the funding challenges as you see them today?
Right. Yes. The actual dollar figures haven't really been fully fleshed out. I think part of the reason is because they're so big, we don't really want to know. But we are working with the T&E Resources Management Center over at USD R&E. We have been working with professional staff members, and actually the new draft NDAA, if it actually gets passed, they recognize our challenges and they're willing to help. And they offered up to $600 million or so investments in T&E infrastructure. But if we really want to revolutionize the way we do T&E, yes, the dollar value is big. I think USD R&E recognizes that. The Department of Defense recognizes that. The congressional staff is recognizing that, and they just want to make sure that before they throw a lot of money at us, that we really know what to do with it. So they're asking us a lot of good questions, and they're offering incremental increases to support the T&E infrastructure and to close the gaps that we have identified.
So a good follow-on question to that is, are you expecting the test ranges themselves to adopt more shift left technologies, for example, simulations on the ranges?
The entire OT&E community is very supportive of the shift left concept, and so is, again, the USD R&E and the TRMC folks. So I do think we have a lot of good support there. They're very supportive of agile T&E, flexible T&E, integrated T&E. I don't know what we might. Well, from the technology infrastructure point of view, we definitely need to do more when it comes to digital transformation. And I think we are making progress, TRMC is, in terms of defining that data architecture, defining the data analytics required for it. There's a program called Cheetah that TRMC has initiated a couple of years ago or so. And I think they're making some good progress. They're doing prototyping and so forth. So I think that's a really good start for us to enable some of the integrated T&E. Workforce, for starters at least, until we automate some of these things, will potentially be a challenge, because now we're asking our operational testers to dig into some of the developmental testing or shift left, which they're not prepared to do right now. So that might be a challenge. But there are certain programs and certain OTAs that have embraced this and that have done this really well. So we got some good prototypes and some good examples of how to do that, but there is no secret that it's definitely straining and stressing the existing workforce to do that, because now they're kind of looking into a scope that they haven't looked into before. But hopefully combining forces, DT and OT, and breaking down those barriers will allow us to leverage the DT workforce and the OT workforce to come up with a more integrated path forward when it comes to T&E.
Excellent. I think we have time for maybe one more question. So we have a few others in the chat, which we can maybe take offline, but so I'll randomly pick Peter's question. Is the challenge related to the introduction of AI into the system in general a problem for T&E of systems? I feel like I read that wrong, but the challenge of AI system, or is it T&E of systems? The issues are different in the two cases. And then Peter's comment is AI only makes an already messy problem more messy. Anything to respond to kind of AI in a system or AI system of systems challenges?
Oh, well, yeah. So, yeah, right. So AI, we're struggling with that. There's a lot of different issues with AI-enabled systems, and I do think that AI-enabled systems will really help us transform T&E. You know, there's a lot of challenges with a system that is learning on its own, and it's learning, you know, based on different environments, and not understanding what that operational environment could potentially look like and how it will respond to that. Really presents a lot of challenges for us in terms of how to evaluate that. And, you know, the system is making decisions based on the information it has at the machine speed. You know, it may come up with an optimal decision that we as testers may have not even thought about. So how do we set the measures of performance for such a system? So for sure, AI-enabled systems are a challenge for us, and we're tackling that. And of course, AI-enabled systems will not operate on its own. It will be operating with another humans and other systems. It will operate in the presence of adversary systems, you know, potentially humans in a loop there. So yes, it does complicate things for us very quickly. But again, we are working with Jake, our Joint Artificial Intelligence Center, to really provide some preliminary guidance to the community on how to tackle some of those challenges.
Well, excellent. With that, I think we are at time, and I'd like to thank you, Dr. Hobson, for making time for this and answering everyone's questions. We really appreciate the presentation. Lots of positive feedback in the comments. So thank you so much for your time, and thanks everyone for attending.
All right. Thank you, Laura. Thank you, everyone.